and this is lecture 2. Lecture 1, we already discussed about turning and related operations. So let's start the video. You can see here an animation of a shaper machine. Just look at this. Shaping and planing. Planning and shaping are similar operations which differ in the kinematics of the process. In shaping, the primary motion is performed by the tool and fed by the workpiece. The workpiece is fed at right angles to the cutting motion between successive strokes of the tool. Planing is a machining operation in which the primary cutting motion is performed by the workpiece and feed motion is imparted to the cutting tool. Workpiece is reciprocated and the tool is fed at right angles to the cutting motion. So there is the differences between shaping and planing. So there are two figures, shaping and planing. Kinematics of shaping and planing. See here the differences. The first one, the cutting speed and feed is difference on the position of the next one for planing. Horizontal shaper. The shaper is a relatively simple machine. It is used fairly often in the tool room or for machining one or two pieces for prototype work. Tooling is simple and shapers do not always require operator attention while cutting. The horizontal shaper is the most common type and its principal components are shown below and described as follows. So this is the shaper machine. See here, tool feed handle, clapper box, tool post, vise, table, adjustable sliding support, cross traverse handle, clutch handle, scale indicator, ram clamping nut, and graduated color. So there are some indicators. Talk about them. Ram. The ram slides back and forth in dovetail or square ways to transmit power to the cutter. The starting point and the length of the stroke can be adjusted. Next one, clapper box. The clapper box is needed because the cutter drags over the work on the return stroke. The clapper box is hinged so that the cutting tool will not dig in. Often, this clapper box is automatically raised by mechanical, air, or hydraulic action. Next one, table. The table is moved left and right, usually by hand, to position the work under the cutter when setting up. Then, either by hand or more often automatically, the table is moved sideways to fit the work under the cutter at the end or beginning of each stroke. Next one, saddle. The saddle moves up and down y-axis, usually manually, to set the rough position of the depth of cut. Final depth can be set by the hand crank on the tool head. Next, column. The column supports the ram and the rails for the saddle. The mechanism for moving the ram and table is housed inside the column. Tool holders. Tool holders are the same as the ones used on at engine lathe, though often larger in size. The cutter is sharpened with rake and clearance angles similar to lathe tools, though the angles are smaller, because the work surface is usually flat. And these cutters are fastened into the tool holder, just as in the lathe, but in a vertical plane. Next one, work holding. Work holding is frequently done in a vise. The vise is specially designed for use in shapers and has long ways which allow the jaws to open up to 14 inches or more. Therefore, quite large workpieces can be held. Work that cannot be held in the vise due to size or shape is clamped directly to the shaper table in much the same way as parts are secured on milling machine tables. Next, shaper size. The size of a shaper is the maximum length of a stroke which it can take. Horizontal shapers are most often made with strokes from 16 to 24 inches long, though some smaller and larger sizes are available. These shapers use from 2 to 5 HP motors to drive the head and the automatic feet. Shaper width. The maximum width which can be cut depends on the available movement of the table. Most shapers have a width capacity equal to or greater than the length of the stroke. The maximum vertical height available is about 12 inch to 15 inch.